Now we want to look at discrete versus continuous data. So what are we going to do? Let us start with an example. Saka example yedu yakamira yakadai so. Tiri kuti in a survey of 1 meter quadrants in a field, the number of snails in each of 30 quadrants was recorded as follows. Saka, our example, we are having a survey, and this survey, it is of 1 meter quadrants. I'm going to explain what we mean by 1 meter quadrants in a field, right? Then the number of snails, the number of snails in each of 30 quadrants was recorded as follows. Saka zvatiri kutaura panapa ndezvekuti tine munda watiinawo. Then munda uyu, this is the area supposedly. Then kana tichiti 1 meter quadrants, zvatiri ngotaura tiri kuti it's a 1 meter by 1 meter area. Satiri kugadzira kabox kadiki 1 meter by 1 meter like this. Saka this is a quadrant. Then we have another one 1 meter by 1 meter tichingodaro, and we are going to have 30 quadrants. Saka you can actually infer what the area of this field is. So this is a survey of 1 meter quadrants in a field. The number of snails in each 30 quadrants was recorded as follows. So I'm not sure if you can see my numbers at now abo. I can just reproduce them quickly. It's 1 2 4 0 2 3 1 4 2 3 5 2 2 3 2 2 3 1 2 3 2 0 1 1 2 0 3 2 3 3. Saka we are calling this discrete data. Takatisina yedu kuspecify. We are currently looking at discrete data. So we can actually put a heading panel. You should edit in the heading in your notes. Discrete data. So if you have consulted our previous lesson, we learned about discontinuous data. Yet it's a type of discrete data. So this is actually discrete raw data. The idea is these are exact numbers of snails. We cannot have a fraction of a snail. Hatigoni kuva ne half a snail, a quarter snail. It's either we have a snail or we do not have. So let us elaborate on this. This is an example of what we refer to as discrete raw data. Saka, this is an example of discrete raw data. We are going to explain what we mean kana chiti raw data. But raw zongoreva kuti unprocessed. Let me preempt. Kuti raw means unprocessed. My observations atatongowana. Maybe we are physically counting the number of snails per quadrant. Saka tapinda quadrant muno tikaverenga ma snails tikaona muine 1. Tikapinda in this quadrant tikaona muine 2. Maybe in the next quadrant taona muine 4. It's possible kuwana quadrant rine 0 kusvika tapedza all the 30 quadrants, making up our discrete raw data. Saka as you can see, discrete data can take only exact values. So ndo zvatiri kuda kudzidzisa panapa. These are exact values. So discrete data can only take exact values. In our yesterday lesson that exact observations and it. Okay, let us look at other examples of discrete data. The other examples of discrete data tinogona kutarisa the number of cars passing a checkpoint in 30 minutes. So the number of cars passing a checkpoint in 30 minutes. Saka tiri kuita zvataita tiri vana especially vakomana kuverenga mota dziri kupfuura parodi. And so the number of cars passing a checkpoint, it's an exact number because we cannot have a fraction or a decimal point for a car. Chiro iri Mini Cooper, we count it as 1. We don't count it as half. The other example would be the shoe sizes of children in a class. The shoe sizes of children in a class. Saka we know kuti ma shoe size, they're exact. We don't have fractions. Hakuna mwana anofeka size 11.5. Say that anofeka size 11 or anofeka size 12. Saka this is also an example. Emphasis iri pakuti there are exact values. Then we can also have another example. The number of tomatoes on each plant in a greenhouse. And it, the number of tomatoes on each plant in a greenhouse. That is also another example. The data are known as raw because they have not been ordered in any way. Saka kana chiti raw data tiringotaura data which has not been ordered in any way. It hasn't been ordered in any way. That is what we are talking about. Pamsoro tanga tati unprocessed data. Saka kuva unprocessed kuripa kuti not ordered. Saka ordering data, it's one of the earliest steps of processing that data. Saka if the data is not ordered, so reva kuti it's raw. Raw tukutora pa kuva mbishi kana kusabikwa. Sort of kubika iri a metaphor of ordering and also processing the data in question. Okay, let us now go to continuous data. We are only defining data types. Teachers will end up processing data types later in our lesson plan. Saka, continuous data. Now looking at continuous data, the following data were obtained in a survey. We are also going to start with a survey example. Saka the following data, Ratichaisa table 2, was obtained in a survey of the heights of 20 children in a sports club. Saka tukutarisa a survey of the heights of 20 students. The heights of 20 students in a survey, cannot in a sports club, sorry. Saka what are the heights? And tisati tenda ikoko, teacher specify our degree of accuracy. Each height was measured to the nearest centimeter. I'm going to explain what we mean by this. So each height, it was measured to the nearest centimeter. Okay, let me put the table and then we have further explanations. So this is our table. Saka takatora a survey of the heights of 20 students in a sports club. tirubva tati each height was measured to the nearest centimeter. Saka kana tichiti each height was measured to the nearest centimeter, we are saying, for example, tikatora the height of this student ane 133 centimeters, and this height 133 centimeters, it has actually been, we can actually say it has been reduced to the nearest centimeter. Kureva kuti the actual height is going to be in a range. Saka, let me write it as a point. The actual height is in a range. And example yatatora 133 centimeters, what is going to be the range? From 132.5 centimeters to 133.4 centimeters. This is going to be the range. Saka, we do not actually know the actual value of the height, but we know that it's going to be in the range 132.5 centimeters to 133.4 centimeters. Saka, that is the example of continuous raw data. Rows chingoreva kuti unprocessed or unordered. Continuous data cannot take exact values. Sata kuchitarisa ma characteristics. This is more like repetition, but repetition makes perfect. Saka continuous data, it takes no exact values. An exact value, it's a whole number. Saka if it doesn't take exact values, sorry kuti, it does not take whole numbers. Even though our table is made up of whole numbers, but trukuziva kuti these are what we refer to as approximations. They are not exact values, they are what we refer to as approximations. Okay. The continuous data cannot continuous raw data values. The continuous raw data values are expressed in ranges or are given only in a specified range, are expressed in a specified range. And we have given an example. Patatora the value 133 centimeters. Tikati the range is going to be 132.5 centimeters to 133.4 centimeters. Somewhere in between this range, the actual height of this first student number 1. Okay, let us take this example again, year 133. Saka manyorero andaita panapa anga angore ekuillustrata the range, but azo manyorero atinoita tinonyora in what we refer to as, we can call it set notation. Saka if we take the example of 133 centimeters given to the nearest centimeter, this could have arisen from any value in the interval 132.5 centimeters to 133.4 centimeters. But manyorero atinozoita macho ndeyekuti, saka our example, if we take and 133 centimeters, this is to the nearest centimeter, tirikuti the value could have risen from the range. Manyorero atinoita range chayo ndeaya 132.5 centimeters is less than or equal to, let us represent height with the letter H, but h is also going to be less than 133.5 centimeters. The reason why this is not necessarily accurate is, what if kana tiine 133 point, let us say tine 0.45 cannot 0.43 for example. And saka because we can actually have other values panapa to account for my values ari konoko anoita kuti our range rambe iri true, panapa we are then going to say less than 133.5 centimeters. Saka pekutanga panapa tiri kuti 132.5 and centimeters is less than or equal to h. Saka take note kuti tati less than or equal to, yet panapa takuchiti the same h will be less than 133.5 centimeters. If we wanted to put this on a number line, h tinenge tina 132.5 tozoita 133.5. Saka 132.5, which is the minimum, we should know that we are having range edu should have a minimum and a maximum. It's going to be included, and it then see this maximum 133.5 is excluded. Saka our true value is within this range. That is what we are talking about. Saka panapa nangopa a simplistic example isiri accurate. This is how you accurately represent it. So you have to be careful, especially part x dot h is less than 133.5 centimeters. If there are any issues, you can ask in the comments. Otherwise, let us give other examples. So other examples would be the speed of a vehicle as it passes a checkpoint. Saka speed of a vehicle. Tinongona kuti mota iri kufamba iri mu 120, but we don't necessarily mean kuti mota iri mu 120. Kukana iri mu 120.4. Murukona. So that is continuous raw data. The mass of a cooking apple, and the mass of an object is also an example. Kana izvo zvimi mukati ndinorema 100 kgs. Kukana iri 100.003. It's continuous, it's not exact. Then we can also talk about the time taken by a volunteer to perform a task. Saka time taken for a task, it's also an example. Saka this is what we had pakungoita illustrate this. What is going to be in our next lesson? Sometimes we have to tell you what is in our next lesson. So our next lesson we are going to look at another data type, but this data type now is ungrouped versus grouped data. If you have derived any meaningful knowledge from this lesson, may you consider liking, subscribing and sharing. If you want to join our private class doing A-level statistics, you can WhatsApp us on +263 71 521 3310. Thank you and have a nice day.